let's record the session. I think it's, yeah, it's recorded. Perfect. All right, so last week, I just remind you, last week we, we discussed different ways to compute the average. So we discussed, so first we had the mode. Second, we had the median. And then the mean. Right, and we said the mean, this is like the most common average, right? This is like the most common average. Right, then we said sometimes using the mean has some disadvantage because you have some exceptional values very different from the other values, and then those exceptional values that will affect your mean, right? So so we said the idea probably is to use, so instead of the mean, we can use what we call the trimmed mean. So the trimmed mean. Okay. So the trimmed mean, just to remind you, what's the trimmed mean? So that's the mean of is the mean of the data of the data values left after after trimming okay, the percentage of the smallest and the largest of the smallest and largest or highest largest values of the data. All right. So the steps. So if you wanna find or compute the trimmed mean, so how do we compute the trimmed mean? So first step, we said we need to order. First, you need to order the data values. Like what we do when we compute the median. So we need to order the data values. Okay. Then we need to compute like 5% of. So we need to find or compute 5% of the data values, and then delete the top and the bottom uh, 5% of your values. Okay. So the 5% you need to round, let's say, to the nearest integer, the nearest. So we need to round to the nearest whole number. And then the last step, step 3, just compute the mean of the remaining data. In the last step, I'm going to compute the mean of the remaining data. Okay. All right, so let's have an example. Example 1. So we're going to have a.
Excuse me?
Yes, please.
That word is depict.
Which word?
Compute 5% of data values and depict.
No, delete.
Oh, delete.
Yeah, sorry, my L is not, sorry, yes. That's delete, yes. Yeah, so yeah, first example. So example one, right? Let's say we have the following data. So the following data represent like a random sample of so the following data. So it represents a random sample, of winter wolf packs size. Okay, in some different regions in, let's say, in Russia or in US, in some different regions. Oops. So in different regions, let's say in the US. All right, so the first pack size is, let's say we have, let's say a 2. We have like 18, let's say how many wolf packs? We have like 18. Okay, so we have like 2, 2, 3, 4, then let's say 5, 7, 7. The size of the next pack is, let's say, 13 here. And then we have 2 again, 3, 4, 4, 7, 7, 8, 10. And then the last pack size is 15, right? So how many packs we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. That will be 18. Perfect. All right. So I'm going to show you how to compute the well. First, let's compute the mean. Okay. So one, we're going to try to compare the mean to the trimmed mean, right? So first, we compute the mean, just the mean, right? So the mean, of course, just to remind you the formula, that will be the sum of all the values, right? And divided by, the number of data values, right? That's supposed to be the mean. Right, so like here in this case, of course, the mean, we have like 18 numbers, right? We have 18 numbers, so we're going to divide by 18, right? This is the number of data values. We have 18 numbers. Now the sum, of course, of the data values, that would be like 2 plus 2 plus 3, plus 4, etc. We have like 18 numbers plus etc. So the last number, of course, would be 15, right? And then we are supposed to divide by the number of data values. We have 18 numbers, right? So the mean, actually, I mean, if you compute the sum here in the top, like 2 plus 2 plus 3, etc., the sum would be 111 over 18. Okay. So 111 over 18, that would be actually 6.2. So what we are saying here is that the mean, so the average of the wolf pack size here is 6.2, right? So that's like the mean or the average of the wolf pack size. Okay. Now we're going to compute the trend mean, right? Two. So let's compute the trend mean. The trend mean. Okay. So as a first step, we are supposed to order the data. Step one. So we are supposed to order the data values, right? We of course from the smallest to the largest. So the smallest data value would be 2, of course. So we have how many 2s? We have like three 2s, right? So it's like 1, 2, 3. And then after that, we have 2 3s. So 3, 3, and then 3 4s. So 4, 4, 4, 1 5, just 1 5, and then 4 7s. 4 7s. There is 2 8s. 1 10. 1 13, and 1 15. Okay. So I ordered my data values. Of course, if you have like 3 2s, you have to write down the 3 2s, not just 1 2, right? It's we have 3 2s, so it's we keep the same number of data values. All right, that's the first step. Step number 2, we are supposed to compute or find what will be the 5% of your data values.
Professor, do you always have to find 5%? Is that a general
like
thing?
that? Yeah. Mm-hmm.
Okay.
That's like the percentage we use all the time. Yes, 5%. So we're gonna delete like the 5% of data values from the smallest and from the largest data values. Yes. So first, let's start with the 5%. So again, this 5%, that's, yes, we always use 5%. So we have 18 numbers, right? 18 numbers or data values, right? So the question is, what will be 5% of the 18 numbers? Well, so what's 5% of 18? So what we do is we just multiply the 5%, by 18. So we'll multiply. So we always multiply the percentage by the number of data values. So we'll multiply. Okay. So 5% times 18. Okay. Now, what's 5%? So again, the percent symbol, that's like division by 100, right? This is a symbol here. This is the percent, right? The percent symbol, and it means division by 100. So when you see this symbol, it means division by 100. So it's just it means division by 100. So this 5%, it's like 5 over 100. Okay, that's exactly the same thing. When you say 5%, it means 5 over 100. That's all it means, okay? Now, 5 over 100 times, and we need to multiply by 18. Now, just be careful. I mean, this is like, this is a multiplication of a fraction with a whole number. So what we do, guys, the 18, it's like, it's a whole number, of course, but I mean, if you want to make it like a fraction, you can divide the 18 by 1, right? This is like 18 over 1. It's the same thing. 18, it's 18 over 1, okay? So now, how do we multiply two fractions? We just multiply straight across, like 5 times 18. You know, you just multiply straight across here. So like 5 times 18 over the 100 times 1, okay? So this is just a 5 times 18 over 100 times 1, okay? And of course, the 100 times 1, I mean, any number times 1 will be the same number. So this is just, you know, 5 times 18 in the top over the 100 in the denominator. So if you have like, instead of 18, you have like, I don't know, 40 numbers, right? So what we do is we multiply 5 by 40 over 100. Here we have 18 numbers. So we multiply the 18 by 5, and then we divide by 100, okay? So then the answer, of course, so you just multiply the 5 by 18. So that will be 90 over 100. And, you know, just use your calculator to divide 90 by 100. That's 0.9. So then we said we need to round to the nearest whole number, right? So your number line, you know, you have like 0, you have 1, you know, this is 0.9, right? This is like, here is like 0.5, you know, this is like, I don't know, 0.1 here, etc. 0.9, it's very close to 1, right? So the closest whole number to the 0.9, of course, would be 1, right? So so in this case, the 5% of the 18 data values. So here the conclusion is, so the 5% of 18 is actually approximately 1, okay? So again, here you need to round. So here, round your answer to the nearest whole number, or integer, nearest whole number.
And this is the formula to find the trim.
Yes, yeah, that's the formula, yes.
Okay.
Again, here I have 18 numbers, right? So in a different example, let's say I'm gonna do another example, right? As I said, as I promised, we're gonna do an example where we compare, let's say, the mean to the median to the trim mean. But let's say you have like an example with 60 numbers, right? So that would be 60 times. So here it's 18, but if you have like 60, that'll be 60 times 5 over 100, right? So and then you need to round your answer to the nearest whole number. So what we need to do in the next step, so in the step 3, so we have to delete like one number, because the answer here is 1. So we need to delete like one number from the top and one number from the bottom, like one number from the smallest data values, one number delete one number from the smallest, and one number from the largest. Largest data values. So let's come back to first step. Here's my data values, right? So I'm gonna delete one number from the smallest. So the smallest numbers, of course, are 2, right? So I'm gonna delete one number from the smallest data values. Oh, there's a question in the chat or something in the chat. Yanin, you cannot hear. Do you hear me, guys? I mean, anyone else?
Yeah, we
Yeah.
can hear you.
Okay. Okay.
I hear you.
Yanin,
Yes, I can hear
probably.
you, Professor.
Okay. Thank you, Edward. So Yanin, I guess that's probably it's a problem with your computer or something, or microphone. I don't know. Yeah. So yeah, we delete one number from the smallest values and one number from the largest number from the largest data value. So we need to delete the 15. Okay. So one number from the bottom and one number from the top. Now we are left with
to Westchester Ridge Hill. We are open daily at 11 a.m. To hear our hours of operation, please press 1. You can place a takeout order online at
So we always do that,
www.yard.com.
Professor? We use,
Or
that's step what? This is step 1, right?
yes, that's from step 1.
So
you
step
can-
1, we always take the smallest and we always take the largest.
Yes, but here because sorry, I need to unmute someone, I guess.
Our dining room is currently open.
This is a lot of information.
Our hours of operation are 11 a.m. to 9 p.m. daily.
Sorry, 1 second. Sorry, okay. Sorry, guys.
Hello, thank you for calling your house to Westchester's Ridge Hill.
Okay, I found the person. Okay. Yes. So, Kayla, you said that's a lot of informations. Well, I mean, you know, all you have to do is to follow the steps. I know it's a lot, but I mean, with the practice, you'll see it's not that bad. I mean,
But Professor, when we have our test, right?
yes,
Is our test gonna look like our homework?
yeah, of course. Yeah.
Like it's all gonna be like that? Or, cause I remember like the last
Yeah, I mean-
class that I watched,
Mhm.
you had like these Greek letterings.
Yeah, the Greek, it's just a notation. Like because like in the textbook, if you check your textbook, you'll see like this notation. I mean, you need to understand the notation, right? Because that's what we use like in the textbooks. But the main thing is you need to know how to apply the formula, right? So like for the mean, I mean, you don't really care about the notation, right? The X bar over the N or the capital N or wherever. But if you know how to compute, how to apply the formula, that's what matters, right?
Because like if I have the form, like when I do the homework, as long as I understood the like the class, I can watch the video and do the work. But I notice like for myself, like when I look at the paper and I try to do it without like looking, my mind is going blank.
Yeah, but that's why actually you're allowed to have like a formula sheet in the test.
That formula sheet was awful.
No,
I didn't even understand it like that.
No, but that formula sheet is it's actually provided by the department, right? So
Yeah.
guys, like in your test on the final, you're allowed to have the formula sheet, the one provided by the department, the
Yeah.
one I gave you. Then you are also allowed to have like your own formula sheet. So you can write down in this formula sheet, you can write down whatever you want. So like the way you understand the formulas, right? So you're allowed, like in the test and or in the final, you're allowed to use like two different formula sheets, right? The one provided by the department and your own formula sheet. Okay?
So then I should probably like go back to all these videos.
Yeah.
And
Mhm.
and make my own formula sheet as I'm going.
Yes. So actually my advice would be to, like to have an example. Just write down, like in the formula sheet, I would write down like an example, how to find, for example, the trim mean. Instead of the formula, I would just write down an example. Okay. Yeah.
Okay.
Mhm. But when we're gonna have the test and or the final, I will give you more details. Okay.
Because I'm just nervous as I'm doing this work that it's so much information that
Yeah, I know.
I can't fail this class or I can't get into biology.
Yeah, I know. I mean, this is, as I said, this is all about formulas. We're gonna have like a lot of formulas, And the point is to know which formula you need to apply.
Okay, thank you.
Mhm. I see some messages in the chat. So Nival, I got you. Thank you. Can you didn't get the formula? Oh, it's on the CUNY Blackboard. So there is a formula sheet on CUNY Blackboard. If you don't see it on CUNY Blackboard, just send me an email. I can send you the formula sheet, but it's on CUNY Blackboard. You can find it on CUNY Blackboard.
Okay.
So yeah, so we delete the smallest data value and the largest data value. Of course, here, if you're like in your answer, well, the answer here is 1, but let's say your answer is 3, then you're supposed to delete like 3 numbers, the 3 smallest numbers. Like you would, if the answer is 3, then you need to delete like the first 3 twos, right? And then you need to delete like the 10, the 13, and the 15. Okay. Let's say if your answer is 3, here the answer is 1. That's why I deleted only the smallest number and the largest number. Okay.
So to get it, I'm sorry because I got disconnected.
Yeah,
So
sure.
when we delete 1 from the bottom and 1 from the top, you're talking about the smallest integer and the largest, and it's the actual number, not subtracting from that number.
Yeah, the actual number. Yes, the actual number.
Okay. Thank you.
All right, now we need to compute the new mean, right? After deleting the 2 and the 15. So in this, the step, I guess. So this is like, I guess, step 4. So we need to compute the mean of the remaining data values. So what's left after deleting the 2 and the 15, right? So that's what I mean here by the remaining data values. So what's left after deleting 2 and 15. Okay, so your trimmed mean would be equal so here we're gonna have like 2 twos, right? So if you delete the first 2, we are left with 2 twos now, right? So we have like 2 twos, so that's like 2 plus 2, right? Plus 3 plus there's another 3, etc. But then the last number, of course, in this case, the last number, it's not 15. So the last number is going to be 13, right? So last number would be 13. All right, here's a question for you guys. So now we're going to need to divide by what? Do we divide again by 18?
By the size of the
16.
sample.
16, yes, the size, yes. 16, because we deleted like 2 and 15. We deleted 2 numbers, right?
2 and 2, yeah.
So then we are left with 16 numbers. So we need to divide by 16 now. Okay, so because we deleted 2 numbers. Okay, so now your trimmed mean would be equal to, so the top, I mean, if you do the top, I think it will be equal to 94 over 16. And I think the answer would be 5.9. So
do we have to round that too? Or
no,
we don't round that?
no, you don't round this. No, not the mean or the trimmed mean. You see, I mean, again, the idea, guys, is I mean, when you take a look to the data values, in some sense, you have the 2s, you have the 3s, you have the 4s, 5s, 7s, But then, the 15 is kind of kind of different. Well, it's not that different, but still, the difference with the twos, the threes, and the fours, the 5, 7. I mean, the 15 is kind of higher, much more higher than the for example, the 8 or the 7, right? So if you compare your trim mean, which is 5.9, sorry, to the original mean was 6.2. Okay. So as you can see, the trim mean is less than the original mean, right? And that's because we deleted like a kind of a very high data value, which is in the 15. Okay. So this is just the remark here. So the trim mean here in this case is less. It's less than the mean, the original mean. The original mean was 6.2, right? And that's because we deleted like a kind of a very high number, which is 15. Okay, that's because we deleted a high number, which is 15. All right. So here's an exercise for you guys. And as I promised, I will go over the median too at the same time. So this is exercise. This is actually exercise from the textbook. Exercise, I think that'll be exercise 23. So I'm gonna just take the exercise 23 page, I think 102, okay, from the textbook. All right, so what does it say, this exercise? So it's about how expensive is, well, is that Miami? I don't see it. Oh yeah, probably Miami. Yeah. Okay. Yeah, so how expensive is Miami? Let's say, so if you want a vacation, a vacation rental condo, so we have the following costs in dollars, of course, per day for a random sample of condos, okay, in Miami. All right. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 20 numbers. All right. So we have 80. Oops. So we have 89, $50 second condo per day, 68, 60, 375. This one is kind of very expensive. Brittany, you're saying the trim is the sum of all number of data values, but after deleting the 5% of the smallest and the largest data values. So you see this sum here, the trimmed mean, the 2 plus 2 plus 3, etc., plus 13.
Yeah.
But this is after I deleted like the first. You see here, I deleted the first 2 and the 15. Okay. So yeah, you do the sum of all the numbers, the remaining numbers, right? After you delete the 2 and the 15.
Great, thank you.
Yeah, so we have this condo at $375 per day, kind of very, very expensive, I guess. Then you have $55. We have 500, very, very expensive. 71. We have 40. We have $350 per day. 60. 50. 250. We have 2 condos, $45 per day, 125, 235. There's a condo with $65 per day, it's 60, and then 130. Right, I think we have 20 numbers here, right? 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18, 20. Yes. All right, here are the questions, guys. So first, oops. So please, first try to find find the median, find the mean, find the trimmed mean, and then in the last question, compare the mean to the trimmed mean. Okay, and you think does the trimmed mean does the trim mean more is it more accurate, reflect the general level of daily rental costs? So in some sense, if the trim means more accurate than the the mean. All right. All right, guys. So I'm gonna give you let's say 5-10 minutes to think about this problem. Just to remind you how to find the median. I mean, if you for some reason forgot how to find the median, so just remind you here. So to find the median, so first step, you need to order the data values, and then you need to find the center or the middle position. Okay, and then once you find the middle position, then you can find the median. So again, the median is supposed to be the number in the middle position of your ordered data values. So as I said, guys, I mean, besides the homework, if you wanna practice like, if you wanna do more exercises, like in the syllabus, in the last page, you can find a list of suggested problems. So if you have your textbook, you can go to your textbook. There are plenty of exercises, and actually, you can even find like you can find the answers to the problems. Of course, you will find like the final answer, not like the steps, right? Um, so yeah, so if you want to practice, you can use your textbook. You can try to solve the problems in your textbook, and again, you can find the answers and see if you're, of course, if you can get the correct answer, right? Um, and like in general, we're gonna do a lot of problems from the textbook, right? So, but of course, the homework I mean, it's not from the textbook. So here in this exercise, we have 20. This is a sample, and the size of this sample is 20. We have 20 data values, right? I mean, Miami, I think it's kind of expensive too, but of course, New York, it's more expensive. But the rent in Miami, it's not cheap, I think. I mean, because I spent some time there, so I know it's not cheap. And your again, your homework number 2, it's where is it? Right, your homework number 2, it's due this Thursday. So please don't forget your homework number 2. So in the homework number 2, there's I think there's an exercise which covers, you know, the histograms, ogives, etc. And there is 1 or 2 exercises, probably I forgot, covers the mode, you know, the median and the mean. So after the trimmed mean, there is the weighted average. This is very common average. We use the weighted average. So for example, when we compute the grade, like the final grade, we use a weighted average. So we have still there's the weighted average after the trimmed mean, and then what else? Weighted average. Yeah, and then I think we are done. After the weighted average, yeah, I think then we are done with the averages, and then we can move to the variance.
I have a question.
Yes, yeah, please.
So I have the median, like I have all the numbers, but it's so long to even find the center. How should I position it?
Yeah, how did you find the middle, the center?
I can't find the middle yet because I have so many numbers.
Okay, so okay, good, okay, that's good. So That's a good point because, okay, let me remind you how to find the middle position, right? To find the middle or the center. So what we do is, so the position of the center. So we take the number of data values, like here we have 20, number of data values plus 1, okay, plus 1 over 2.
Oh,
All right. So so like here we have 20 numbers. So that's like 20 plus 1 over 2. So 21 over 2, and that'll be 10.5. Okay. So in other words, the position of the center, it's not exactly a number. It's actually between two numbers. So 10.5, 10.5 is between 10 and 11, right? 10.5 is between 10 and 11. So so the middle or the position of the center would be between the 10th and the 11th values.
okay.
You just count, after you order. First, of course, you need to order your numbers, right?
Mhm.
And then you count. You need to find your 10th and your 11th. And then, so the median would be the 10th number plus, or the 10th value plus the 11th value. So the median would be the 10th value plus the 11th value, and then divide by 2. We take the average of the two numbers.
Okay.
But here, because I got a decimal, right, 10.5. And in this case, because we have 20 numbers, we have the even number of numbers. But if you had like odd numbers, number of numbers, like if we had like, I don't know, 25 numbers, then the position of the center is going to be given exactly by a number. It's not between two numbers. It's going to be exactly one number.
So it would only be the number that I was left with if it's odd.
Yes.
Okay.
But in both cases, you can use the same formula. This one here, the position of the center, you can use this formula for position of the center in both cases, right? Odd or even, doesn't matter. You can always use this.
Thank you.
And we can use
And I'm always gonna divide by 2 because I'm trying to figure it out. Okay.
yeah, the middle, yeah.
Okay.
Actually, it's a lot of numbers, right? It's like 20 numbers.
Yeah, because what I thought was when I write the numbers out,
Mhm.
like when I finally have them in order and stuff, that I was supposed to like go side by side, like,
Yeah.
and I'm like, no, I'm doing something wrong.
Yes, I know. That's the thing. These formulas sometimes are useful when you have like a lot of numbers. It's not, then it's not easy to find the center. Yes. Did anyone find the median?
I thought it was 10 and 11.
No, I'm saying the median would be the 10th number, the 10th value plus the 11th value over 2.
Oh, okay.
I mean, you need to find the 10th position plus the number in the 11th position, and then over 2.
$10.5. No, right?
No, because what you are doing is you are just adding.
He's talking about the place value, not
Yeah,
to
I'm talking
add
about
those
that.
numbers.
Yes,
Like you have to, if you still have to order them, and then you still have to count to that number. So let's say the first number is 40, 45, 45 again. You have to count like 1, 2, 3 till you get to the number 10 and 11. In those two numbers, you do that formula.
Oh, okay.
So
Thank
the
you.
number, the position, yeah, and the position, the 10th position, plus the number in the 11th position.
Is this 66.5?
Yes, it's a 66.5. Thank you. Yeah, so the answer for number 1 should be, answer for the median should be 66.5. So if you didn't get the 66.5, guys, you have trouble with the median, please let me know. I can probably try to explain how we get the 66.5. So I don't know if you have a trouble with median.
I am.
Kayla, do you still have trouble?
Yeah, I just want to see you write it out.
Yeah, so, okay, all right. Let me do this then. All right, so first you need to order, the data values from the smallest to the largest. And the smallest, as you can see here, is, yeah, the smallest data value would be, where is it? 40, right? So we start with 40. So we have 40, and then we have 45, right? We have two 45s, right?
Mm-hmm.
And 50, yes, we have two 50, one, right? And then there's 55. There is 155, right? We're about 60. We have 2, 3, 60, right? So we have 1, 2, 3, 60s, and then 65. Do we have 65? Yes, we have 165. Just 165. Please correct me if I miss something. Then there is a 68, right? And then 70, there is 71, actually, I see 71.
89.
89.
125.
The 125, right?
Mm-hmm. 130.
Yeah, 125. And then 130, right? There's
Mm-hmm.
130. There's
235.
235, thank you.
250.
250.
350.
350, thank you. And then the 375. And then
Oh,
500.
Okay.
Right, so let me just count how many numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. That's very good. All right. So as I said, the median would be the number in the 10th position plus the number in the 11th position. So let's count. So this is the first position, right? This is first number, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So this is my number
Oh, okay.
10th position. So this is,
So it's 133.
10th plus the number in the 11th position. So this is my number in the 11th position. So that will be 65 plus 68 over 2. And that's how we get the 66.5. So
Yeah, but it's 133. See, that's where I'm getting confused because I'm thinking that it's 65 plus 68, which is 133.
yeah,
You're
over
dividing
2.
it?
Yeah, you divide by 2. You take the average.
So you add it. I'm adding the 10th and 11th, and after I add it, then I need to divide it.
But yeah, you need to divide by 2. Yeah.
That's where I made the mistake because I wasn't dividing.
Yeah.
I was just adding.
You need to
Okay.
take the average of the two numbers. So it's 60, 65, 68 over 2, as you said. So that will be 133 over 2. So the answer is 66.5. And that will be the median.
Okay, I understand now. Thank you.
All right, now, so we have the median. Now, next we need to find the mean. The mean is gonna be, so number 2. So the mean would be, well, yeah, some of the numbers, 40 plus 45 plus 45 again. All the numbers, we have like 20 numbers, right? Plus the last number is 500. Now, we need to divide by the size of the sample. We have 20 numbers, so we need to divide by 20. We have 20 numbers. We have 20 values. Okay. And the mean, so the answer, if you do that, then the answer, the mean would be, I think 1. So X bar, this is a notation for the mean. That will be 136 dollars points, so 15 cents, I guess. So 136.15. That will be the X bar, the mean. So as you can see, I mean, the mean is like the X bar, the mean is like the double, twice the median, right? Twice the median. All right, so that's the mean, that's the average. Now the trim mean. Okay. So again, why do we bother ourselves with the trim mean? Because as you can see here in the prices here, the rents here, you have like a very small kind of a very small rents like with $40, $45, right? But then there are some condos that are very expensive, with the $500 per day. That's very expensive, right? So the idea of the trim mean, so we're gonna try to have like more accurate mean. Okay, so first step 1, we need to order the data values. Okay, so this was done, right? I mean, we did it when we computed the median, right? The median. All right, now step 2, we need to find the 5% of data values. What will be the 5% of data values? So it's 5% times, so how many values we have? We have 20 values, right? The size of the sample is 20. So we 5% times 20. we always multiply, right? The percentage by the size of the sample. It's 5%, it's just 5 over 100. That's what we mean by the percent. It's division by 100. It's 5 over 100 times the 20. Okay. And as I said, the 20, it's like it's in the top, right? So this is like 5 times 20 over the whole thing over 100. So that's 5 times 20, that's 100 over 100. I mean, 100 over 100, of course. I mean, a number divided by itself, it's always 1, right? A non-zero number, of course, divided by itself is always 1. So we need to delete one number one number from the top and from the bottom. Okay, so oops, sorry about that. So we need to delete the smallest number. Where is it? Here. So you need, of course, first you order your data values. Now we delete the smallest number, which is in this case 40. Okay, and you delete the highest number, which is 500. So now in the trim mean, we're gonna start. So the sum of data values. So we start with 45, right? So now step 3. So in the trim mean, so we start with the 45 now. 45, right? So I have like 2 45s, right? So we deleted the 40. So we start with 45 plus 45 plus 50 plus another 45 plus 50 plus etc. And now the last number is not 500 anymore, right? Now the last number would be 375. So plus 375 plus 375. And now be careful. I mean, I know from my experience, this is where a lot of people made a mistake. So when you divide here, we don't divide by 20 because we deleted 2 numbers, right? So we need to divide by 18. Okay, just be careful here. So we divide by 18 because we are left with 18 numbers. Okay. Anyway, so if you do this, the answer, the trim mean should be equal to 121.28. So the trim mean would be $121, $121.28, right? So it's true.
Excuse me, Professor, does the trim mean has a special symbol?
Nope.
Okay, thank you.
Now, if you compare the trim mean to the mean, guys, as you can see, the mean is like $136, right? The trim mean is now like 121, okay? And as I said, so the trim mean now is less. So the trim, this is less. So this is less than the mean, the original mean, right? Than the original and the mean, which was 136.15, right? And that's because we deleted one of the largest values here, the $500 per day. You can imagine like a condo with $500 per day. That's very, very expensive. Okay, so I mean the trim in some sense now the trim mean represent the data better than the better than the mean, and that's because of those exceptional values like this $500, which is very, very expensive, right, compared to the other costs, right? So yeah, so the trim mean is more, in this case, the trim mean is more accurate than the mean. So the trimmed mean is more accurate than the mean. And that's because, because of this $500, right? That's so expensive. That's very expensive compared to the other values. So once you delete this $500, you can get more accurate mean, I guess. All right, are there any questions, guys, about the trim mean? So that's how it works, the trim mean. All right, so now let's finish with the last average. This is very common average, the weighted average. Weighted average. Okay, so actually that's what I use, for example, to compute your final grade, like in this class. I use the weighted average, to compute to compute your final grade. Okay, so what's this weighted average? Well, so as I said, so I use the weighted average to compute your final grade. Okay, so what's the weighted average? So roughly speaking, the weighted average, that's a type of it's a type of mean where some values. So this is a type of mean where some values have some more importance. So where some values, data values, of course, in the data, where some values in the data are given, or are given more importance than others. Okay. Example. So I'm gonna do first an example, and then with the example, I'm gonna show you I'm gonna try to explain the formula. Okay, example. Okay. Let's say the grading system for this class let's say grading system for this class or for another class, for a class. So let's say the homework they're worth let's say 30%. The midterm, say the midterm is 35%, and the final exam is 35%. Okay. Of course, in this class, we have homework worth 25% actually, and we have 2 tests. Each test is worth 20, and then there's a final 35%. But anyway, let's say we have this grading system for a class, and let's say a student, suppose a student got, so actually the 30% for the homework, 35% for the midterm, 35% for the final. So these percentages here are called the weights. So this is what I call the weight. This is, so the weight of the homeworks is actually 30%. So this is the weight of the homeworks. The 35%, that's like the weight of the midterm. The weight of the midterm. And the weight of the final, it's actually 35%. Okay, so the percentages here, guys, they represent the weight. This is the, so the 35%, this is the weight of the final. Anyway, so so we suppose we have, let's say a student got, let's say, suppose a student, so suppose that a student got, like, let's say 85%, 85 out of 100, in the final, and then 90%, 90% or 90 over 100, let's say in the midterm. And then let's say 100% the homeworks. Okay. So the question is, you need to compute the grade, the course grade, right? So let's compute the course grade. Okay. So what we are supposed to do here is, so you take, for example, you start with, let's say, the homeworks, right? So we said the homeworks, oops. Okay. Sorry about that. So the homeworks, they're worth 30%, right? So the average, the weighted average in this case, the weighted average, so would be equal to, so homeworks, so the student, he got 100% of the homeworks, right? 100% of the homeworks, right? So it's 100%. Okay, 100% of the homeworks times, and then we're gonna multiply by the weight of the homeworks, or how much worth of the homework, right? So the homeworks are worth 30%, right? As you can see here, homeworks are worth 30%. So we're gonna multiply the grade in the homework by the 30%. So times, times here 30%. Okay, 30%. So the 30%, that's the weight of the homeworks. Okay, plus, now midterm. So the student got 90% of the midterm, right? So it's 90%. The midterm, right? Times, and then we need to multiply by the weight of the midterm. So the midterm is worth 35%, right? As you can see here. So the midterm is worth 35%. So we need to multiply the grade of the student in the midterm by 35%. So we'll multiply here by 35%. Plus, So the 35% again, that's the weight. That's what I call the weight of the midterm. This is the weight of midterm. Okay. And finally, plus, so the student grade on the final is 85%, right? That's the student, as you can see, we got 85% on the final. So plus 85%, 85%. And then we multiply by the weight of the final. So the final is worth 35%, right? So multiply by 35% the grade, the student grade in the final times 35%. Then we're gonna divide by the sum of the weights. So the homeworks are worth 30%. Midterm is worth 35%, and plus the final is worth 35%. So here we divide by the sum of the weights. Anyway, guys, so this is how we actually we compute the course grade. It's called the weighted average. So next time I will give you the formula for the weighted average. I mean, this is just an example, of course. But so next time I'll give you the formula for the weighted average, and probably we'll do more examples. All right, guys. I guess I'm gonna stop here, and yeah, and hopefully I'm gonna see you tomorrow. Okay. I will give you more details about this weighted average.